In this video we're going to look at the first question about vertical motion under gravity. Hopefully you've got the notes for this to go alongside it as well. Just one page of notes. Best thing to do is just to look at examples. So let's have a look at number 1, part A. So as is often the case with these, we're going to draw a little diagram. So we've got an idea of what's going on. We can picture and visualise what's happening in the question. So a book falls off the top shelf of a bookcase. So let's draw our bookcase. And have our book, so we'll model our book as a particle in this case. So let's say our book starts right at the top here and it's falling down from there. So our positive direction we're going to treat as this way. And that distance from the bookshelf from the floor, this distance here, is 1.4 meters. So that'll be S. And we know initially when our book falls, its initial velocity will be 0 meters per second. And obviously eventually it's going to reach the floor here and have its final velocity. And we also know that our acceleration due to gravity is 9.8 meters per second, and because we've treated the positive direction as down, that'll be going down the page. So the time taken for the book to reach the floor. So here we've got U, we're looking for T, we've got S, 1.4 meters, and we've got A, which is 9.8 meters. So this is just like a particle going horizontally. I'll get rid of the meters there, get rid of the units, sorry. Except we're going up and down instead, but it's the same kind of idea. We could kind of draw this horizontally if we wanted to, but it makes more sense with gravity to draw it up and down. So we've got S, U, and A. So we're going to look through our equations. If you want to write them out at the side to help you identify which one to use, then you can do. And sub in. So U is 0, so this will be 0. A half, A is 9.8, and T squared is our time. So 1.4 is a half of 9.8, which is 4.9. Sorry, let me just adjust this. And then divide by 4.9 and square root. And we get our answer for T, which should be 0.5345, etc. So T is 0.535 seconds to 3SF. So this is part A here. Let's find the time taken for the book to reach the floor, and we also want to find the speed with which the book hits the floor for part B. So in part B, book is going to get to the bottom, and we'll call this V, and it'll be in meters per second. So we have our velocity that it gets to. So we can use V equals, well, we've got U again is 0. We've now got T if we want. We can use S again if we want to, but we've got T. Just make sure you use the exact value. Let's get rid of the rule there. And we've got A, which is still 9.8 meters per second squared. So V equals U plus AT. Sub in V equals 0 for U, A is 9.8, and T is the value we've just found. Use the exact value, put that in your calculator, and you should get 5.238. So 5.24 meters per second when it hits the floor to 3SF. That's question 1.